Here are 50 most commonly asked scenario-based interview questions and answers for AWS Cloud Security engineer interviews of freshers or entry-level pros.
Scenario 1. A developer accidentally pushed AWS access keys to GitHub. What will you do?
Answer: I would execute an immediate technical containment and forensic investigation strategy. Step 1: Containment. Immediately deactivate the compromised access key in the IAM console using the Update Access Key command. Do not delete it yet. Step 2: Investigate. Perform a forensic audit. Query AWS Cloud Trail logs via Amazon Athena to identify if the key was used by unauthorized IP addresses to spawn resources. Step 3: Remediate. Isolate any suspicious workloads, generate new credentials for the developer, and scrub the GitHub repository history using tools like BFG Repo Cleaner or Git Filter Repo. Step 4: Prevent. Shift to keyless authentication. Implement OpenID Connect (OIDC) for GitHub Actions to eliminate the need for long-lived static credentials entirely. Interview tip: why this is secure. Deactivating rather than deleting the key is a forensic best practice. It preserves the access key ID in the system, allowing you to accurately filter cloud trail logs to determine the exact blast radius of the leak. Shifting to OIDC ensures that even if a repository is compromised, there are no permanent secrets to steal.
Scenario 2. You find an IAM user with administrator access. How would you handle it?
Answer: I would use a data-driven approach to enforce least privilege without breaking the developer's production workflow. Step 1: Validate usage. Check the last access column in the IAM console to verify if this is an active human user or a highly vulnerable service account. Step 2: Audit telemetry. Use AWS IAM Access Analyzer and CloudTrail to review the exact API calls the user has actually made over the last 90 days. Step 3: Generate scoped policy. Use the Access Analyzer to automatically generate a custom IAM policy based strictly on their historical activity, replacing the broad admin policy. Step 4: Implement guardrails. If they occasionally need admin rights, implement AWS IAM Identity Center to provide just-in-time JIT temporary elevated access. Interview tip: why this is secure. This process replaces guesswork with telemetry-based security. By generating a policy from actual cloud trail events, you reduce the attack surface by over 90% while guaranteeing the developer remains productive. JIT access further minimizes risk by ensuring administrative powers only exist during active work windows.
Scenario 3. An application running on EC2 needs to upload files to an S3 bucket. How do you grant access without hard-coding AWS access keys in the code?
Answer: I would implement a secure keyless access pattern using IAM roles for EC2. Step 1: Create an IAM role. Define a role with a trust policy that allows the EC2 service, ec2.amazonaws.com, to assume it. Step 2: Apply least privilege. Attach a policy granting only required permissions such as S3:put object on the specific S3 bucket ARN. Step 3: Attach role to EC2. Associate the IAM role with the EC2 instance via an instance profile. Step 4: Automatic credential usage. The application uses AWS SDK, which automatically retrieves temporary credentials from the Instance Metadata Service, IMDSV2. No credentials are stored in code. Interview tip: why this is secure. This approach eliminates hard-coded secrets, provides automatic credential rotation via AWS SDS in the backend, and reduces the risk of credential leakage. Mentioning IMDSV2 shows strong security awareness against SSRF attacks.
Scenario 4. A user cannot access an S3 bucket despite having IAM permissions. How would you troubleshoot?
Answer: I would methodically check the AWS policy evaluation logic, as an explicit deny always overrides an allow. Step 1: Check IAM policies. Verify no explicit deny exists in the user's attached identity-based policies or permission boundaries. Step 2: Check S3 bucket policy. Review the resource-based bucket policy to ensure it does not block the user's ARN or require a specific condition like an exact IP address. Step 3: Check VPC endpoint policies. If the EC2 instance is in a private subnet using a VPC gateway endpoint, Ensure the endpoint policy allows the S3 get object action. Step 4. Check KMS key policies. If the S3 bucket uses SSC KMS encryption, verify the user's IAM role has KMS decrypt permissions in the key policy. Interview tip. Why this is secure. This structured troubleshooting covers defense in depth. In AWS, access is not just about IAM. It is a combination of identity, resource, network, and encryption layers. Proving you check the KMS key policy specifically differentiates you from beginners.
Scenario 5. An IAM role cannot be assumed by an AWS service. What checks would you perform?
Answer. I would investigate the trust relationship and the permissions of the entity passing the role. Step 1. Check the trust policy. Verify the principal block in the role's trust relationship exactly matches the service, for example, lambda.amazonaws.com. Step 2. Verify action. Ensure the trust policy explicitly allows the SDS:(assume role action. Step 3. Check pass role permissions. Ensure the user or CI/CD pipeline attempting to attach the role has the IAM:(pass role permission for that specific role ARN. Step 4. Check SCPs. Verify that an AWS organization service control policy is not globally blocking the SDS:(assume role action for that specific OU or region. Interview tip. Why this is secure. Separating the trust policy, who can be the role, from the permissions policy. What the role can do is a core security boundary. Monitoring IAM:(pass role is vital because it is a common vector for privilege escalation, where an attacker tries to attach an admin role to a resource they control.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 6. How would you detect privilege escalation attempts in AWS IAM?
Answer. I would architect a continuous monitoring and alerting pipeline using AWS native security services. Step 1. Enable guard duty. Activate Amazon Guard Duty to detect anomalous IAM behaviors, such as unusual API calls from new IP addresses using machine learning. Step 2. Monitor Cloud Trail. Create Amazon Event Bridge rules filtering Cloud Trail logs for high-risk API calls like IAM: attach user policy or IAM: pass role. Step 3. Automated alerting. Route those event bridge triggers to an SNS topic that pages the security team via PagerDuty or Slack for immediate triage. Step 4. Config rules. Use AWS config managed rules to continuously evaluate if any user receives administrator access and auto-remediate by detaching the policy. Interview tip. Why this is secure. Modern attackers do not use malware in the cloud. They use legitimate administrative APIs. A security as code approach using Event Bridge and AWS config ensures that unauthorized privilege changes are detected and reversed in seconds, not months.
Scenario 7. How do you securely store and manage secrets in AWS?
Answer: I would implement a centralized, encrypted secrets management strategy to keep hard-coded credentials out of source code. Step 1. Choose the service. Use AWS Secrets Manager for high-value secrets like database credentials and Systems Manager Parameter Store for standard configuration data. Step 2. Enforce encryption. Encrypt all secrets at rest using AWS KMS Customer Managed Keys, CMK, to ensure strict cryptographic control and auditing. Step 3. Least privilege retrieval. Assign an IAM role to the application that only grants Secrets Manager: gets secret value for that specific secret ARN. Step 4. Automated rotation. Configure Secrets Manager to use a Lambda function to automatically rotate database credentials every 30 days without application downtime. Interview tip: why this is secure. Centralized management provides a single point of audit. By combining KMS encryption with automated rotation, you ensure that even if a secret is stolen, its time to live is limited, effectively neutralizing long-term credential compromise.
Scenario 8. A third-party vendor needs temporary AWS access. How would you provide it?
Answer: I would establish a secure cross-account access architecture without creating standard IAM users for the vendor. Step 1. Create a cross-account role. Create an IAM role in our account and set the vendor's AWS account ID as the trusted principal. Step 2. Require an external ID. Enforce a unique external ID condition in the trust policy that the vendor must provide when assuming the role. Step 3. Apply least privilege. Attach an inline policy granting the exact minimum actions required, such as read-only access to a specific S3 bucket. Step 4. Session limits and auditing. Set a strict maximum session duration for the role and actively monitor the vendor's activity using AWS Cloud Trail logs. Interview tip: why this is secure. The external ID is the only architectural defense against the confused deputy attack. It ensures that the vendor cannot be tricked into using your IAM role to access your data on behalf of a different, malicious client.
Scenario 9. How would you identify and manage unused IAM users and roles?
Answer: I would implement an automated lifecycle management process to reduce the account's attack surface. Step 1. Credential reports. Regularly generate the IAM credential report to identify users with passwords or access keys that have not been used in 90 days. Step 2. Access Analyzer. Use IAM Access Analyzer to generate reports on unused IAM roles and unused permissions attached to active roles. Step 3. Event-driven automation. Write an AWS Lambda function triggered by Event Bridge that automatically deactivates access keys older than 90 days. Step 4. Notification workflow. Before deletion, the automation sends a notification to the key owner giving them a 7-day grace period to claim the credential. Interview tip: why this is secure. Hygiene is a security property. Unused credentials are silent vulnerabilities that attackers hunt for. By programmatically deactivating dormant keys, you eliminate the risk of a legacy backdoor being exploited without affecting active business operations.
Scenario 10. How would you enforce least privilege across an entire AWS organization?
Answer: I would enforce a layered defense in-depth strategy, moving from global governance down to individual resource tags. Step 1. Service Control Policies, SCP. Apply SCPs at the AWS organization's root level to set absolute maximum permissions, such as denying the ability to disable Cloud Trail. Step 2. Permissions Boundaries. Require developers to attach a predefined permissions boundary to any IAM role they create, preventing them from elevating their own privileges. Step 3. Prevent wildcards. Use infrastructure as code scanning tools in the CI/CD pipeline to block any deployment containing broad wildcards like action:**. Step 4. Attribute-based access control ABAC. Shift to ABAC by writing policies that grant access based on resource tags, allowing security to scale dynamically as new resources are added. Interview tip: Why this is secure. This layered guardrail approach ensures that security is enforced by the system, not by human memory. SCPs provide the safety net, while a back allows permissions to scale with the business without the need to manage thousands of static, hard-to-audit roles.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 11. An S3 bucket is publicly accessible. How would you detect and fix it?
Answer: I would implement an automated detection and remediation loop to ensure data sovereignty and prevent unauthorized exposure. Step 1: Detection. Use AWS Config Managed Rules or Amazon S3 Access Analyzer to continuously monitor bucket policies and access control lists for public read or write permissions. Step 2: Immediate triage. Enable block public access at the specific bucket level, or ideally the AWS account level, to override any existing permissive policies instantly. Step 3: Automated remediation. Configure an AWS config remediation action that triggers an AWS Systems Manager automation document to reset the bucket policy to a private state upon detection. Step 4: Prevention. Implement a service control policy at the AWS organizations level that globally denies the ability to disable block public access settings for any bucket in the production OU. Interview tip. Why this is secure. This self-healing approach reduces the mean time to remediation from hours to seconds. By layering service control policies as global guardrails over bucket-level settings, you establish a default deny posture that cannot be bypassed by individual developers or compromised credentials.
Scenario 12. How would you enforce encryption for all S3 buckets and EBS volumes?
Answer: I would implement a global encryption by default posture using account-level settings and automated guardrails. Step 1: Account defaults. Enable Amazon S3 default encryption and EBS encryption by default at the account level to ensure all new resources are encrypted automatically. Step 2: Key strategy. Mandate the use of AWS KMS Customer Managed Keys, CMK, to ensure independent rotation and strict access policies over AWS managed keys. Step 3: Inline policy blocks. Apply S3 bucket policies that contain a deny statement if the upload request does not include the S3:XAMS server-side encryption header. Step 4: Organization guardrails. Use a service control policy, SCP, to globally deny any create volume or create bucket API call that attempts to set the encrypted attribute to false. Interview tip. Why this is secure. This multi-layered approach removes reliance on developer behavior. By enforcing encryption at the organization and API levels, you establish a fail-safe environment where unencrypted data simply cannot exist.
Scenario 13. An RDS snapshot was accidentally made public. What will you do?
Answer: I would execute an immediate containment and forensic assessment to prevent database exfiltration. Step 1. Revoke visibility. Immediately use the modify DB snapshot attribute command to set the snapshot visibility back to private in the RDS console. Step 2. Cloud Trail audit. Search Cloud Trail logs for the modify DB snapshot attribute event to identify the identity responsible and the exact timestamp the leak began. Step 3. Data access review. Check database audit logs and VPC flow logs to identify if any unusual data transfer patterns occurred from unknown IPs during the exposure window. Step 4. Automated shield. Enable the AWS config rule RDS snapshots, public prohibited with an auto remediation action, to instantly flip snapshots to private if detected. Interview tip: why this is secure. Public snapshots allow anyone with an AWS account to copy your entire database. Automation via AWS config reduces the time to remediation to seconds, effectively neutralizing the human error before it can be exploited.
Scenario 14. How do you ensure secure data transfer between AWS services?
Answer: I would enforce encryption in transit using protocol-level mandates and certificate automation. Step 1. Enforce TLS. Set a minimum requirement of TLS 1.2 or higher for all service endpoints and load balancers, disabling legacy, insecure SSL protocols. Step 2. Certificate management. Use AWS Certificate Manager, ACM, to provision and automatically rotate public and private SSL/TLS certificates for internal and external traffic. Step 3. Policy conditions. Add a deny statement to S3 bucket policies and SQSQ policies where the AWS secure transport condition is set to false. Step 4. VPC endpoint strategy. Use interface VPC endpoints private link to ensure traffic between VPCs and AWS services never leaves the private AWS global network backbone. Interview tip: why this is secure. The secure transport condition is the most critical guardrail here. It physically prevents any data from being sent over unencrypted HTTP, ensuring that man-in-the-middle attacks are impossible at the network layer.
Scenario 15. What controls would you apply before storing sensitive PII in S3?
Answer: I would implement a privacy-first ingestion pipeline with automated discovery and data masking. Step 1. Automated discovery. Use Amazon Macy to continuously scan the target buckets for sensitive data like credit card numbers or government identifiers. Step 2. Tokenization. Implement a Lambda function to tokenize or redact sensitive fields before the data reaches the storage layer, replacing PII with non-sensitive tokens. Step 3. Resource isolation. Store PII in dedicated, high-security buckets with data events logging enabled in Cloud Trail to track every single access attempt. Step 4. Key management. Use a dedicated KMS customer-managed key with a highly restrictive key policy that only allows a specific reader role to decrypt the data. Interview tip: why this is secure. By tokenizing data before it hits S3, you move the security boundary from the storage layer to the application logic. This drastically reduces the compliance audit scope for frameworks like GDPR and PCI DSS.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 16. How would you protect S3 data from accidental or malicious deletion?
Answer: I would build a multi-layered durability strategy using versioning and physical multi-factor gates. Step 1. S3 versioning. Enable versioning on all production buckets so that delete operations only create a delete marker, allowing for instant recovery. Step 2. MFA delete. Enable MFA delete on the bucket, which requires a hardware MFA token to permanently delete a specific version of an object. Step 3. S3 object lock. Use object lock in compliance mode for regulated data to make it immutable worm, meaning no one, including the root account, can delete it. Step 4. Cross-region replication. Replicate critical data to a separate security account in a different region, providing a clean copy in case of account-wide compromise. Interview tip: why this is secure. MFA delete is the gold standard for durability. It ensures that even if an administrator's credentials are stolen, the attacker cannot permanently destroy the data without physical access to the MFA device.
Scenario 17. A developer disables encryption on a resource for testing. How would you handle it?
Answer: I would treat this as a policy violation and use automated remediation to restore the security posture. Step 1. Automated detection. Use AWS config rules, for example, S3 bucket server-side encryption enabled, to detect the change in real time. Step 2. Auto remediation. Trigger an AWS Systems Manager, SSM, document to automatically re-enable encryption and notify the security team via Amazon SNS. Step 3. Permission scoping. Update the developer's IAM role to remove the KMS:disable key and S3: put bucket encryption permissions, preventing them from making the change again. Step 4. Root cause. Investigate why the developer felt the need to disable security. Often this indicates a need for better IAM training or a more flexible dev/Q environment. Interview tip: why this is secure. Relying on manual audits is too slow. Self-healing infrastructure ensures that your security baseline is maintained 24/7, regardless of human intent, keeping the organization compliant and protected at all times.
Scenario 18. How do you monitor and audit access to sensitive data in S3?
Answer: I would enable granular data plane logging and behavioral analysis to detect suspicious patterns. Step 1. Cloud Trail data events. Enable S3 data events. Get object, put object for sensitive buckets, which are not logged by default in standard management trails. Step 2. Guard Duty S3 protection. Activate Guard Duty S3 protection to alert on behavioral anomalies, such as an identity suddenly listing and downloading millions of objects. Step 3. S3 access logs. Enable server access logging to capture detailed requester information, including the IP address and HTTP status codes for every request. Step 4. Metric alarms. Set Cloud Watch alarms on S3 bytes downloaded metrics to trigger an alert if the daily egress volume exceeds the standard baseline by 20%. Interview tip: why this is secure. Standard Cloud Trail only logs bucket-level changes. By enabling data events, you create a non-repudiable audit trail of who exactly touched the data itself, which is a mandatory requirement for SOC 2 and HIPAA audits.
Scenario 19. How would you securely share S3 data across different AWS accounts?
Answer: I would implement a secure cross-account access model using resource-based policies and KMS key sharing. Step 1. Bucket policy. Add a statement to the source bucket policy that allows S3: get object access specifically to the IAM role ARN in the destination account. Step 2. KMS key policy. Update the key policy of the KMS CMK to allow the external account's root or specific role to perform KMS: decrypt operations. Step 3. Role assumption. If the external user needs to upload data, use SDS: assume role so they act as an internal identity, ensuring the source account retains object ownership. Step 4. Secure transit. Mandate that the cross-account request includes the AWS secure transport condition to ensure the data is never exposed over the internet. Interview tip: why this is secure. Using IAM roles and bucket policies is significantly safer than using ACLs or long-lived cross-account keys. It provides a single point of revocation. If the partnership ends, you simply delete the ARN from your policy.
Scenario 20. How would you detect data exfiltration attempts from an S3 bucket?
Answer: I would build a detection system based on volume and behavioral heuristics. Step 1. Behavioral guard duty. Use Amazon Guard Duty to detect discovery: S3/anomalous behavior, which flags when a user performs massive reconnaissance before a theft. Step 2. Egress monitoring. Use VPC flow logs to identify large volumes of traffic leaving the VPC storage subnets to external, non-AWS IP addresses. Step 3. Cloud Trail API spikes. Monitor for a sudden spike in list objects or list buckets calls followed by rapid GET object requests from a single user identity. Step 4. IP reputation. Cross-reference requester IP addresses in S3 access logs with known malicious IP lists or unauthorized geographic regions. Interview tip: why this is secure. Exfiltration detection is not just about blocking access. It is about pattern recognition. Attackers often compromise a legitimate credential and then move slowly to avoid detection. Monitoring volume bytes and speed API frequency is the only way to catch them.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 21. An EC2 instance is publicly accessible when it should not be. How would you fix it?
Answer: I would perform a 3-layer network isolation to remove the exposure and prevent future recurrence. Step 1. Security group lockdown. Immediately modify the security group to remove the 0.0.0.0/0 inbound rule and restrict access only to the corporate VPN or load balancer. Step 2. NACL review. Verify that the subnet's network ACL is not allowing broad inbound traffic that bypasses the security group's stateful protection. Step 3. Routing triage. Check the VPC route table. If the instance is in a private subnet, ensure it does not have a direct route to an internet gateway, IGW. Step 4. Organization policy. Implement an SCP that prevents any user from attaching an internet gateway to a VPC tagged as internal only or production data. Interview tip. Why this is secure. This defense in-depth approach ensures that even if one layer, like a security group, is accidentally opened, another layer, like the route table or SCP, acts as a safety net to prevent actual traffic exposure.
Scenario 22. A security group allows 0.0.0.0/0 access on multiple ports. What would you do?
Answer. I would execute an immediate remediation and auditing workflow to remove the open world exposure. Step 1. Emergency triage. Immediately remove the 0.0.0.0/0 entry from the security group and replace it with the specific IP ranges of the corporate VPN or a known proxy. Step 2. Identify scope. Use AWS config rules, VPC SG open only to authorized ports, to identify every other security group in the account with similar misconfigurations. Step 3. Audit owners. Check CloudTrail for authorized security group ingress events to identify who created the rule and why the standard security review was bypassed. Step 4. Technical guardrail. Implement an IAM policy for developers that includes a condition block, preventing the creation of security group rules with a sitter of 0.0.0.0/0. Interview tip. Why this is secure. This process addresses the human variable. By combining immediate remediation with an IAM condition block, you move from a reactive security posture to a proactive one where broad internet exposure is physically impossible for unauthorized users.
Scenario 23. How would you design a secure VPC architecture for a web application?
Answer. I would implement a standard 3-tier isolated architecture to ensure multiple layers of network defense. Step 1. Tier isolation. Divide the VPC into public, private, and data subnets across at least 2 availability zones for high availability. Step 2. Perimeter layer. Place the application load balancer in the public subnet and attach an AWS WAF to filter malicious web traffic before it enters the network. Step 3. Application layer. Place EC2 instances in the private subnet with no route to the internet gateway, forcing all outbound traffic through a NAT gateway for security. Step 4. Data layer. Place the RDS database in the data subnet with a security group that only allows inbound traffic from the application tier's security group. Interview tip. Why this is secure. This design follows the principle of network segmentation. By keeping the application and database tiers in non-routable private subnets, you ensure that an attacker who compromises the public load balancer cannot directly reach the sensitive data layer.
Scenario 24. A vulnerability scan shows multiple open ports on an EC2 instance. What is your response?
Answer. I would execute a system-level audit to verify the necessity of the ports and apply a default deny posture. Step 1. Process audit. Log into the instance and use the netstat-tulpn command to identify which specific application processes are listening on those ports. Step 2. Security group alignment. Update the security group to ensure that only the ports required for the application, for example, 443, are open, and close all others immediately. Step 3. Host-based firewall. Enable IP tables or UFW on the Linux instance to provide a second layer of defense inside the OS beyond the AWS security group layer. Step 4. Automated patching. Use AWS Systems Manager Patch Manager to ensure the OS and all listening services are updated to the latest secure versions to prevent port exploitation. Interview tip. Why this is secure. Open ports are the front doors for attackers. By using IP tables inside the OS in addition to AWS security groups, you implement defense in depth. If a developer accidentally opens a port in AWS, the OS-level firewall still blocks the traffic.
Scenario 25. How would you restrict RDS access only to specific EC2 instances?
Answer. I would implement security group referencing to create a dynamic and secure trust boundary. Step 1. Create AppSG, Assign a specific security group, for example, App Server SG, to the EC2 instances that require database access. Step 2. Configure DBSG in the RDS security group. Add an inbound rule for the database port, for example, 5432 for Postgres. Step 3. Source referencing. Set the source of the rule to the ID of the App Server SG instead of a static IP address or CIDR range. Step 4. Clean up. Remove any other inbound rules from the RDS security group to ensure that no other network path, including SSH or standard admin tools, can reach the DB. Interview tip: why this is secure. Referencing a security group ID is superior to using IP addresses. It ensures that as your application scales up and new instances are launched, they automatically receive access, while any instance without that specific SG is blocked by default.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 26. How would you secure APIs hosted on AWS API Gateway?
Answer: I would build a 3-layer security stack focusing on authentication, authorization, and traffic inspection. Step 1. Authentication. Use Amazon Cognito or a Lambda authorizer to enforce JWT-based token validation for every incoming request. Step 2. Layer 7 defense. Attach AWS WAF to the API gateway to protect against common attacks like SQL injection, cross-site scripting, and credential stuffing. Step 3. Resource policies. Apply an API gateway resource policy to restrict access to specific VPCs or known IP ranges, preventing global exposure. Step 4. Throttling. Implement usage plans and rate limiting to prevent API exhaustion attacks and ensure fair usage across different API consumers. Interview tip: why this is secure. API Gateway is the front door to your logic. Combining a WAF with a Lambda authorizer ensures that traffic is inspected for malicious intent WAF, an authorized identity authorizer, before a single line of your backend code executes.
Scenario 27. How do you prevent lateral movement inside an AWS VPC?
Answer: I would implement micro-segmentation to isolate workloads even if they reside in the same subnet. Step 1. Trust security groups. Configure security groups to block all traffic between instances by default, even those within the same application tier. Step 2. Network firewall. Deploy AWS Network Firewall at the VPC level to perform deep packet inspection, DPI, on traffic moving east-west between subnets. Step 3. Service mesh. Use AWS App Mesh to enforce MTLS, mutual TLS, between microservices, ensuring that every service-to-service call is encrypted and authenticated. Step 4. VPC flow logs. Actively monitor flow logs for reject events between internal IPs, which is a primary indicator of an attacker attempting to scan the internal network. Interview tip: why this is secure. In traditional networking, once an attacker is inside the VPC, they can touch everything. Micro-segmentation removes this soft interior by treating every internal connection as if it were coming from the public internet.
Scenario 28. A DDoS attack is suspected on your application. What would you do?
Answer: I would activate the AWS Edge Defense stack to absorb the attack and maintain application availability. Step 1. Immediate visibility. Check the AWS WAF dashboard for a spike in blocked requests and review AWS Shield Global Threat Dashboard for active DDoS events. Step 2. Edge protection. Ensure the application is behind Amazon CloudFront or Global Accelerator to leverage the AWS Global Edge Network for DDoS absorption. Step 3. Rate limiting. Deploy a rate-based WAF rule to automatically block any single IP address that exceeds a threshold of 100 requests per minute. Step 4. Shield Advanced. If subscribed, engage the AWS Shield Response Team, SRT, to apply custom mitigation logic at the infrastructure and network layers. Interview tip: why this is secure. DDoS mitigation is about scale versus scale. By using CloudFront and Shield, you offload the attack to the AWS global network. This prevents the attack traffic from ever reaching your EC2 instances, keeping your compute resources free for legitimate users.
Scenario 29. How would you implement Zero Trust architecture in AWS?
Answer: I would move away from network-based trust and adopt a model where every request is continuously verified. Step 1. Verified access. Use AWS Verified Access to provide secure access to internal applications without a traditional VPN, validating user identity and device posture for every request. Step 2. Identity-centric policies. Use CEDAR-based policies to define granular permissions that consider user attributes, location, and the time of the request. Step 3. Micro-segmentation. Enforce strict security group rules that only allow traffic between specific service identities, regardless of their network location. Step 4. Continuous auth. Implement short-lived sessions for all administrative access, requiring re-authentication for high-risk actions like deleting production data. Interview tip: why this is secure. Zero Trust assumes the network is already compromised. By using AWS Verified Access, you remove the VPN backdoor and ensure that an attacker with a stolen password still cannot access data if their device is not trusted or compliant.
Scenario 30. A misconfigured NACL or route table is found. How would you assess the impact?
Answer: I would use reachability analysis tools to determine if the error created a security hole or a service outage. Step 1. Reachability Analyzer. Run VPC Reachability Analyzer between the public internet and the affected subnets to see if traffic can now bypass our security groups. Step 2. Route Table Audit. Check if the private subnet route table was accidentally modified to include a default route to an internet gateway, IGW. Step 3. Flow Log Review. Analyze VPC flow logs for accept traffic on ports that should be restricted, which confirms if the misconfiguration was actually exploited. Step 4. IAM Audit. Review CloudTrail for create route or replace network ACL entry events to find who made the change, and if they had the authorized permissions to do so. Interview tip: why this is secure. Misconfigurations are the leading cause of cloud breaches. Using Reachability Analyzer provides mathematical proof of connectivity. This allows you to definitively tell leadership if a security gap existed, even if no data was actually stolen.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 31. You detect a login from an unusual geographic location in AWS. What will you do?
Answer: I would treat this as a high-confidence indicator of account compromise and trigger an immediate identity lockdown. Step 1. Session invalidation. Immediately use the IAM console to revoke active sessions for the user, forcing all current CLI and management console tokens to expire. Step 2. Password reset. Reset the user's login password and rotate any active access keys per secret keys to prevent the attacker from re-authenticating. Step 3. Geofencing. Implement a service control policy, SCP, that denies all action: requests unless the AWS requested region is restricted to our authorized countries. Step 4. MFA enforcement. Verify if MFA was bypassed. If it was not enabled, mandate its use for all users before they are allowed to perform any cloud actions. Interview tip: why this is secure. Identity is the new perimeter. Revoking active sessions is the most important step, because even if you change the password, an attacker can still use an existing valid session token to exfiltrate data until it naturally expires.
Scenario 32. CloudTrail is not enabled in your account. What would you do?
Answer: I would immediately establish a global audit trail to restore visibility into all management plane activity. Step 1. Enable multi-region trail. Create a new trail in the AWS Cloud Trail console and ensure the Apply Trail to All Regions option is selected for global coverage. Step 2. Secure log storage. Configure the trail to deliver logs to a dedicated, encrypted S3 bucket with log file integrity validation enabled to detect any unauthorized tampering. Step 3. Organization trail. If part of an AWS organization, I would create an organization trail from the management account to ensure logs from all member accounts are collected centrally. Step 4. Retention policy. Set an S3 lifecycle policy to move logs to Glacier Deep Archive after 90 days for long-term compliance and forensic readiness. Interview tip: why this is secure. CloudTrail is the most critical forensic tool in AWS. Without it, you are effectively blind to who did what, when, and from where. Enabling integrity validation ensures that logs can be used as evidence in legal or compliance audits.
Scenario 33. How would you detect if an AWS account is compromised?
Answer: I would look for indicators of compromise across identity, network, and billing telemetry. Step 1. Guard duty findings. Check Amazon Guard Duty for unauthorized access or Trojan alerts, which indicate communication with known malicious command and control servers. Step 2. IAM anomalies. Review CloudTrail for unusual API calls such as IAM:create user or IAM:create access key from unrecognized IP addresses or geographic locations. Step 3. Network egress. Analyze VPC flow logs for a sudden spike in outbound data transfer to external IPs, which often signals a data exfiltration event. Step 4. Billing spikes. Monitor AWS budgets for unexpected cost increases, as attackers often spin up massive GPU instances for crypto mining or password cracking. Interview tip: why this is secure. Detection is about correlating signals. A single unusual API call might be a mistake, but an unusual login followed by a new IAM user and a billing spike is a confirmed breach. Speed of detection directly limits the cost of a compromise.
Scenario 34. You see a spike in API calls in CloudTrail. What could it indicate?
Answer: I would categorize the spike into three primary risk categories: reconnaissance, brute force, or misconfigured automation. Step 1: Reconnaissance. A spike in describe or list calls, for example, S3:list buckets, often indicates an attacker is mapping your environment after gaining initial access. Step 2: Credential stuffing. Repeated console login failures followed by a success indicates a brute force or credential stuffing attack against an IAM user. Step 3: Automation loop. A massive spike in resource creation, for example, EC2:run instances, might be a broken Terraform script or a thundering herd scaling event rather than a hack. Step 4: Exfiltration. Rapid S3:get object calls across multiple buckets suggest an active data theft in progress. Interview tip: why this is secure. Understanding API intent is vital. By using CloudWatch Logs insights, you can calculate the error rate of these spikes. A high 403 access denied rate during a spike is a classic signature of an attacker guessing permissions.
Scenario 35. How would you implement centralized logging in AWS?
Answer: I would architect a hub and spoke model to aggregate logs into a dedicated security account. Step 1: Log Hub account. Create a separate AWS account specifically for logging and security, isolated from production and development workloads. Step 2: Cross-account S3 bucket. Deploy a central S3 bucket in the hub account with a bucket policy that allows S3:put object access from the entire AWS organization ID. Step 3: CloudWatch Logs destination. Use CloudWatch Logs destinations to stream application and OS logs from member accounts into a Kinesis data firehose in the security account. Step 4: Analysis layer. Connect the central S3 bucket to Amazon Athena or Amazon Open Search Service to allow the security team to search all logs across the enterprise from a single pane of glass. Interview tip: why this is secure. Centralization prevents log silos. If an attacker compromises a production account, they cannot delete the evidence because the logs have already been shipped to a separate, restricted security account that they cannot access.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 36. What would you do if CloudTrail logs were deleted?
Answer: I would treat this as a high-severity critical incident indicating an active attacker attempting to hide their tracks. Step 1: Lockdown identity. Identify the IAM user or role used in the delete trail or delete bucket event, and immediately revoke all its active sessions and permissions. Step 2. Verify backups. Check if S3 object lock or MFA delete was enabled on the logging bucket, as these would have prevented the actual data deletion despite the API call. Step 3. Secondary logs. Pivot to secondary log sources like VPC flow logs, CloudWatch logs, or load balancer access logs to reconstruct the attacker's timeline. Step 4. Hardening. Re-enable the trail immediately and apply an SCP that explicitly denies CloudTrail:"stop logging and CloudTrail:"delete trail for all users except a break glass role. Interview tip. Why this is secure. Log deletion is a confirmatory signal of malicious intent. Advanced architects use S3 object lock in compliance mode to make logs mathematically undeletable for a set period, rendering this attack vector useless.
Scenario 37. You detect crypto mining activity on EC2. How would you respond?
Answer. I would execute a containment first incident response plan to stop the financial and security drain. Step 1. Isolate the instance. Change the security group to a quarantine group that blocks all inbound and outbound internet traffic, killing the miner's connection to the pool. Step 2. Identity revocation. Immediately revoke the IAM instance profile permissions to ensure the compromised instance cannot make further AWS API calls. Step 3. Forensic capture. Take a snapshot of the EBS volume and, if possible, perform a memory dump before terminating the instance for deeper root cause analysis. Step 4. Threat hunting. Use guard duty to identify how the miner was installed, likely through an exposed credential or an unpatched vulnerability in the web application. Interview tip. Why this is secure. Crypto mining is often a distraction attack. While you are focused on the high CPU bill, the attacker might be using the same access to hunt for sensitive data. Containment must happen at the network level first to stop the bleeding immediately.
Scenario 38. How would you configure alerts for suspicious AWS activity?
Answer. I would implement an event-driven alerting pipeline to minimize the mean time to detect. Step 1. Define high-risk events. Identify critical API calls like IAM: deactivate MFA device, STS: assume role, or EC2: modify instance attribute that require instant alerts. Step 2. Event bridge patterns. Create Amazon event bridge rules that match these specific CloudTrail API patterns in real time. Step 3. SNS orchestration. Set the event bridge target to an Amazon SNS topic, which fans out the alert to email, SMS, and your Security Operations Center (SOC) dashboard. Step 4. CloudWatch metric filters for non-event activity like multiple 403 errors. Create a CloudWatch metric filter and set an alarm if the count exceeds 10 within a 1-minute window. Interview tip. Why this is secure. Polling for logs every hour is too slow. Event-driven alerting using Event Bridge reacts in milliseconds. This allows you to respond to a credential theft before the attacker has time to perform a full environment scan.
Scenario 39. AWS Security Hub reports a critical finding. How do you handle it?
Answer. I would follow a triage, validate, and remediate workflow based on the AWS Security Finding Format, ASFF. Step 1. Finding triage. Review the Security Hub dashboard to understand the severity, the affected resource, and which security standard, for example, SIS Foundations, was violated. Step 2. Validation. Verify if the finding is a true positive or a known exception, for example, a purposefully public S3 bucket for a static website. Step 3. Remediation. Follow the remediation instructions link provided by Security Hub. This might involve updating an IAM policy, enabling encryption, or closing a port. Step 4. Automated workflow. For recurring critical findings, I would use Security Hub custom actions to trigger a Lambda function for automated remediation. Interview tip. Why this is secure. Security Hub acts as your security command center. It normalizes findings from guard duty, Macy, and inspector, allowing you to prioritize fixing the critical issues that actually impact your risk posture.
Scenario 40. Walk through your first 30 minutes of handling a security incident in AWS.
Answer. I would follow the containment first approach to minimize impact while preserving evidence. Minute 0 to 5 identification. Confirm the alert, for example, guard duty, or billing spike, and identify the specific compromised AWS account and IAM identity. Minute 5 to 15 containment. Revoke IAM sessions for the compromised user, rotate the affected secrets, and isolate any suspicious EC2 instances using a deny all security group. Minute 15 to 25 forensic preservation. Take snapshots of all affected EBS volumes and enable S3 object lock on any buckets containing audit logs to prevent evidence tampering. Minute 25 to 30 communication. Notify the internal security stakeholders and open a high-severity support case with AWS if infrastructure-level assistance is required. Interview tip: why this is secure. Calmness and structure are the two things interviewers look for. Following a timed plan proves you will not panic during a breach. Containment always comes before investigation. You stop the thief before you count the stolen goods.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 41. A CI/CD pipeline is deploying insecure AWS configurations. How would you fix it?
Answer: I would implement a shift-left security strategy by adding automated guardrails directly into the deployment pipeline. Step 1. Static analysis. Add a stage in the pipeline to scan Terraform or CloudFormation templates using tools like Checkov or TFSec to catch open ports or unencrypted disks. Step 2. Policy as code. Use AWS Cloud Formation Guard to define and enforce specific organizational security rules that must be met before a stack can be deployed. Step 3. Least privilege pipeline. Ensure the CI/CD service role itself is scoped using a permissions boundary, preventing the pipeline from creating unauthorized admin-level resources. Step 4. Dynamic testing. After deployment to a staging environment, run an automated scan using Amazon Inspector to identify runtime vulnerabilities before the code hits production. Interview tip: why this is secure. Fixing a security bug in a template costs pennies. Fixing it after it's been deployed to production costs thousands. Shift left means security becomes a quality gate that code must pass, just like unit tests.
Scenario 42. How would you scan CloudFormation or Terraform templates for security issues?
Answer: I would implement static application security testing, SAST, for infrastructure by integrating specialized scanning tools into the developer workflow. Step 1. Pre-commit hooks. Encourage developers to run Checkov or TFSec locally to catch misconfigurations, like unencrypted S3 buckets, before they even commit code. Step 2. Pipeline integration. Add a mandatory linting and security scan stage in the CI/CD pipeline that fails the build if any high-severity violations are detected. Step 3. Cloud Formation Guard. Use AWS Cloud Formation Guard to write custom policy as code rules that enforce organizational standards, such as no SSH open to the Internet. Step 4. Template Validation. Run the AWS Cloud Formation Validate Template command to ensure syntactical correctness before attempting a deployment. Interview tip: why this is secure. Scanning templates before deployment is the definition of shift-left security. It prevents vulnerable infrastructure from ever reaching the cloud, reducing the workload on your reactive security tools like guard duty and config.
Scenario 43. A container image in ECR has critical vulnerabilities. What would you do?
Answer: I would establish an automated container security lifecycle that blocks the deployment of high-risk images. Step 1. Enable ECR scanning. Turn on enhanced scanning in Amazon ECR, which uses Amazon Inspector to continuously scan images for vulnerabilities, CVE, as they are pushed. Step 2. Triage findings. Use the ECR console or API to filter for critical and high-severity findings that have a fix-available status. Step 3. Implementation of gates. Configure the CI/CD pipeline to check the ECR scan results and block the deploy stage if the image contains any critical vulnerabilities. Step 4. Base image patching. Work with the development team to update the Dockerfile base image to a newer, patched version and trigger a fresh build and rescan. Interview tip: why this is secure. Modern exploits often target known vulnerabilities in outdated libraries. Enhanced scanning provides near real-time visibility into the software supply chain, ensuring that only hardened, approved images are running in your production clusters.
Scenario 44. How do you enforce security policies in AWS deployments?
Answer: I would use a combination of preventative and detective controls to ensure every deployment meets the security baseline. Step 1. Service Control Policies, SCP. Use SCPs at the AWS organizations level to set hard boundaries, such as preventing any deployment in an unauthorized AWS region. Step 2. IAM Permissions Boundaries. Use boundaries to restrict the maximum permissions a deployment role can grant, preventing an automated pipeline from creating admin-level users. Step 3. AWS Config Remediation. Deploy AWS config rules that monitor for non-compliant resources, like unencrypted volumes, and trigger automated remediation via SSM documents. Step 4. Infrastructure as Code, IAC. Only enforce a policy that all production changes must be made through CI/CD, and disable manual click ops in the AWS Management Console. Interview tip: why this is secure. Consistency is the enemy of attackers. By enforcing IAC only and layering SCPs, you eliminate snowflake architectures and ensure that security standards are applied uniformly across thousands of accounts.
Scenario 45. What checks would you implement before deploying to production?
Answer: I would implement a final security gate that combines static analysis, dynamic testing, and manual sign-offs. Step 1. Artifact signing. Verify that the container image or build artifact has a valid digital signature using AWS Signer, proving it hasn't been tampered with in the registry. Step 2. Least privilege audit. Use the IAM Access Analyzer to confirm that the deployment will not accidentally create public-facing resources or cross-account trust relationships. Step 3. Secret integrity check. Ensure that no secrets, API keys, passwords, are hard-coded in the deployment manifest by using a scanner like Trufflehog in the final pipeline stage. Step 4. Staging validation. Perform an automated smoke test in a staging environment to ensure that all security groups and IAM roles are working as expected before the production push. Interview tip: why this is secure. These pre-prod checks act as a checksum for security. They verify that the security posture you designed in development is still intact at the moment of deployment, preventing last-minute configuration drift from creating a breach.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 46. How would you securely manage secrets in AWS CI/CD pipelines?
Answer: I would eliminate long-lived credentials and implement dynamic secret retrieval for the pipeline. Step 1. Use OIDC providers for external pipelines like GitHub Actions. Use OpenID Connect (OIDC) to allow the pipeline to assume an IAM role without storing AWS access keys. Step 2. Centralized storage. Store all pipeline secrets in AWS Secrets Manager or Systems Manager Parameter Store with secure string encryption. Step 3. Runtime injection. Configure the pipeline to fetch secrets at runtime via the AWS CLI or SDK, rather than passing them as environment variables which might be logged. Step 4. Secret rotation. Enable automatic rotation for the secrets used by the pipeline to ensure that even if a secret is leaked, its value is only valid for a short duration. Interview tip: why this is secure. OIDC is the most significant upgrade in pipeline security. It replaces static, stealable keys with temporary, cryptographically verified tokens, effectively eliminating the most common cause of cloud breaches.
Scenario 47. A developer bypasses security checks to deploy faster. How do you handle it?
Answer: I would address this as both a technical governance failure and an educational opportunity. Step 1. Technical block. Implement branch protection rules in the Git repository that require a successful security scan status check before any code can be merged. Step 2. Detect manual changes. Use AWS config or drift detection in CloudFormation to identify if the resource was modified manually. Click Ops outside the pipeline. Step 3. Revoke manual access. Gradually reduce write permissions in the production management console, forcing all developers to use the governed CI/CD path. Step 4. Collaborative review. Meet with the developer to understand why the check was bypassed. If the scan was too slow or gave false positives, I would optimize the security tool. Interview tip: why this is secure. Security that is painful will always be bypassed. The goal is to make the secure path the easiest path. By optimizing the tools and enforcing branch protection, you make security a seamless part of the velocity.
Scenario 48. How would you implement policy as code in AWS?
Answer: I would use declarative rules to define and enforce security requirements across the entire environment. Step 1. Tool selection. Use AWS Cloud Formation Guard for template-level enforcement and AWS Config for runtime-level enforcement. Step 2. Rule definition. Write rules using a human-readable domain-specific language, such as deny if EBS volume is not encrypted. Step 3. Integrated enforcement. Connect these rules to the CI/CD pipeline and the AWS organization's delegated administrator for security. Step 4. Audit and alert. Ensure every policy violation is logged centrally in Security Hub and triggers an Amazon SNS notification for the security team to review. Interview tip: Why this is secure. Policy as code replaces human manual review with machine speed enforcement. It ensures that your security requirements are documented as code, version controlled, and applied 100% consistently every time.
Scenario 49. How do you ensure continuous compliance in AWS?
Answer: I would move away from point-in-time audits to a real-time detective and remedial posture. Step 1. AWS Security Hub. Use Security Hub to aggregate security scores against industry standards like the AWS Foundational Security Best Practices. Step 2. AWS Config Recording. Enable continuous recording in AWS Config to track the configuration history of every resource and detect drift from the compliant state. Step 3. Automatic remediation. Use AWS Config Conformance Packs to apply a set of rules and remediation actions across the entire organization automatically. Step 4. Compliance Dashboards. Create a QuickSight dashboard for leadership that shows the compliance health score of all accounts in real time. Interview tip. Why this is secure. Traditional compliance is like a yearly health check. Continuous compliance is like a 24/7 heart monitor. It ensures that you are not just secure on audit day, but secure every single second of the year.
Scenario 50. A misconfiguration caused a security breach. How would you analyze and prevent it?
Answer: I would execute a blameless post-mortem and root cause analysis (RCA) to turn the failure into an architectural guardrail. Step 1. Timeline reconstruction. Use Cloud Trail and VPC flow logs to create a minute-by-minute timeline of how the misconfiguration was exploited. Step 2. Gap identification. Determine why our existing controls, guard duty config, WAF, did not detect or block the specific exploit path used by the attacker. Step 3. Implement new guardrail. If a manually open port was the cause, I would implement an SCP or a config auto remediation rule to prevent that specific port from ever being opened again. Step 4. Update the pipeline. Add a new test case to the CI/CD security scan that specifically looks for the pattern that caused the breach, ensuring the mistake can never be repeated. Interview tip. Why this is secure. This feedback loop is the most advanced part of security engineering. You do not just fix the bug, you fix the process that allowed the bug to exist. This creates an ever-hardening environment that gets stronger after every incident.
Congratulations! You are now ready for the AWS Cloud Security interview.
We have covered 50 of the most high-impact, real-world scenarios you will face as a cloud security engineer in 2026 plus interviews. From the basics of IAM and S3 to the complexities of OIDC pipelines and policy as code, you now have the mental frameworks to answer like a pro. Remember, an interviewer is not looking for a walking encyclopedia. They are looking for an engineer who can protect the business when things go wrong.
The 3 pillars of a winning interview.
As you walk into your next interview, keep these 3 principles in mind. 1. Automation over manual work. Always suggest a self-healing or event-driven solution rather than a manual check. 2. Defense in depth. Never rely on just one control. If you suggest a security group, also suggest a NACL or an OS-level firewall. 3. Shift left. Advocate for catching security issues in the IDE or the CI/CD pipeline before they ever hit production. The textbook gives you the definition. Experience gives you the guardrail.
Final call to action.
If this 50 scenario masterclass helped you understand AWS security at a deeper level, hit the subscribe button and join our community of architects. Check the link in the description to download the complete PDF guide and the architect interview bundle. Have you faced any of these scenarios in your own work? Let us know in the comments below. I read every single one. Good luck with your interviews, and I will see you in the next masterclass.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers. For 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.